The next thing to look at is what is known as partial derivative. And this is just a summary of what partial derivative is, right? What we'd have learned from Unit 1. We'd have learned from Unit 1 that we can find f prime of x by this. F prime of x is the limit as h tends to 0 of f of x plus h minus f of x divided by h. Now, in reality, we can extend this to a function of two variables or more. All right, so we find the derivative of a function with respect to one variable while holding the other as constant. So for example, if z is equal to a function f of xy, right, then we can find this fx really mean we're differentiating the function with respect to x. And so y is held a constant. And so it is the limit as h tends to 0 of f of x plus h comma y minus f of x over h. Now, fy of xy, this is really saying that we're keeping x constant and we're differentiating the function with respect to y, right? And so this is given by f of x comma y plus h minus f of xy over h. Now, wherever these limits exist, this fx is known as the first partial derivative of the function with respect to x. And this fy means the first partial derivative of the function with respect to y. And that's all is partial derivative. So it's very important. So this fx, first partial derivative with respect to x of the function f of xy. And so fx of xy, this just means that we're finding the differential of the function with respect to x. So we'll write it sometime as dou f by dou x. They don't write d because it's partial derivative. So we'll call it dou f by dou x. Or sometimes it's just fx. And also fy, this just means that we're differentiating the function f of xy in terms of y. And so f of fy, this is fy, so fy of xy is equal to dou f, differentiating the function f with respect to y. Alright? So here we've write it down better. As we said, if z is f of xy, then the first partial derivative of x is represented by dou z by dou x, which is dou f by dou x, which is fx of xy. And the first partial derivative of y is represented by dou z by dou y, which is dou f dou y, which is fy, which is dou by dou y of f of x. Alright, so to find dou f by dou x, we differentiate the function with respect to x and keep y constant. Finding dou f by dou y, we differentiate the function with respect to y and keep x constant. These are the first partial derivatives. Now, there are what is known as second partial derivatives, and the second partial derivatives are fxy, means you differentiate the function with respect to x first, then differentiate it with respect to y. Then fyx, we differentiate the function with respect to y, then differentiate it with respect to x. Fyy mean we differentiate it with respect to y, then we differentiate it with respect to y again. And fxx mean we differentiate the function with respect to x twice. Now a function is continuous if and only if fxy is equal to fyx. So let's look at an example. Let's look at two examples. Right? So let me say, for example, f of xy is equal to x squared plus y squared minus 2xy. Let's say this is a function, right? F of x is x squared plus y squared minus 2xy. Now look at this now. To find, let's use y cubed, right? Just to change it up. X squared and y squared. Yeah, let's change it up. Let's say y cubed. Just to change up the question a little bit. Let it a little more challenging. Now, from this now, we can find the first partial derivatives. So the first partial derivatives, so the first partial derivatives, so the first PDs mean the first partial derivatives of the function, which is given by fx, and fx is really equal to dou f by dou x. That's the first partial derivative. And dou f by dou x is equal to, when we differentiate this function with respect to x, we're going to get 2x plus this y cube becomes a constant, because when you're differentiating with respect to x, y is a constant. And so this y cube becomes 0 when we differentiate it, minus this y is like a constant, this y is a constant, and so we're differentiating minus 2x times some constant k, and so we just get minus 2y. So that is dou f by dou x. It is just 2x minus 2y. Now let's say we wanted to find now fy, which is the first partial derivative with respect to y. And so what we're getting then, fy is equal to dou f by dou y. And dou f by dou y is equal to, we're going to differentiate the function with respect to y. And so what we're going to get then is, differentiating the function with respect to y, we're going to differentiate x squared is now a constant, because we're keeping x as a constant and differentiating with respect to y. So differentiating x squared, we get 0, plus differentiating y cubed with respect to y is just 3, carry down the power and subtract 1 from the power, so that's 3y squared. Minus, your 2x is now like a constant, right? And so it just becomes minus 2x. So that would be fy. So those are your first partial derivatives. Let's say we wanted to go ahead now, proceed and find our second partial derivatives. So let's do that in a different color. Let's go for blue, true blue. And so what we're going to do now is find our second partial derivative, which is fxy. And to find the second partial derivative, which is fxy, this just means that we differentiate with respect to x first and then differentiate with respect to y. That's what that means. So we differentiate the function with respect to x first and then differentiate the function with respect to y. So some people might write it as dou 2f by dou y dou x, which really means we're finding dou by dou y of, we're differentiating the function first and foremost with respect to x. And so what we're getting then is fxy, meaning we're differentiating the function of x with respect to y. And so what we're getting then is, now we had already found dou f, right? And so remember, fx, we said that dou f by dou x we found is 2x minus 2y. And so all we need to do then is find dou by dou y of dou f by dou x, where dou f by dou x is 2x minus 2y. So it's dou by dou y of 2x minus 2y. Now we're going to find dou by dou y of 2x minus 2y. And that's going to be equal to, now differentiate 2x with respect to y is 0. And differentiating minus 2y with respect to y is just minus 2. So the result is minus 2. Now, the next one we can find is then f of xy, which we're pretty much just gonna, first we're going to, we just found f of xy. Let's find now f of yx, which is finding f of yx. F of yx just means we're gonna find the derivative with respect to y first, and then differentiate that with respect to x. So that's equal to dou by dou y, dou by dou x rather, of dou f upon dou y. But dou f upon dou y we found was right here, 3y squared minus 2x. So this was 3y squared minus 2x. And so what we're getting then is that this is working out to be f of yx is working out to be, we differentiate it with respect to x, we're just getting minus 2. Nice. Now let's say we're going to find fxx. As fx suggests, we're differentiating dou f upon dou x with respect to x. So again, we're differentiating this. So we're just going to find dou by dou x of dou f upon dou x, which is we're differentiating 2x minus 2y with respect to x. And so what we're getting is 2. Now let's say we're going to find f of yy. F of yy just means that we're finding dou by dou y of dou f upon dou y. And so dou by dou y of this one now is going to be dou by dou y of 3y squared minus 2x. Now differentiating this with respect to y, what we're getting is 6y. From these results, what we can conclude is, from the second derivatives, remember, since, what can we conclude now? Since f of xy is equal to, f of xy is equal to negative 2 and fyx is equal to negative 2, then we can conclude that this function is continuous. So since fx is equal to fyx, then f is continuous. Then f is continuous. So CONT stands for continuous. So the function is continuous. And that wraps pretty much up partial derivative. Easy, soft.